Hi. The main purpose of doing this is I'm not going to finish the problem for you. It's to show you the value of doing the practice exercises and also to practice setting up diagrams on simple problems first before you get to problems like this one. So obviously we need to chop down this diagram. It's too complicated, it's far too busy. What are we actually looking for? Okay, so first of all, are we looking for x? Now the answer to that is no. We are not actually looking for x. We're actually looking for this distance here. Now I'm going to add, I don't often do this, but I have to put another letter in there. I'm going to call it h, and this distance here is going to be ch. I'll actually clean that up just a bit. Now I'm not going to clutter up this diagram either. I'm going to start breaking some triangles out, and the first one I'm going to take, before I do that I should keep track of what I've just said. I must keep a note of what I'm doing. I am going to actually use an h there, and I'm going to write down here that x, which is what I am looking for ultimately, is equal to ch plus 0.9. Now in this triangle I can see that because the lines are vertical, I can put a horizontal line across there, and that is showing my distance ch a bit more clearly. And I actually know, because this is horizontal and that's vertical, there's a right angle in there. Now I must redraw this triangle because I can't, it's a mistake to work with it there. I'm going to redraw it. There's the first line. Okay. And very importantly, I'm going to use all my labels. X and C and A. Now if I'm stumped again, let's choose a different line. I want to find this distance here in red. Okay, it's a right angle triangle. What do I need? I need some sides, I need an angle. Now what can I possibly get out of this, the rest of this diagram? Okay, there's another triangle which has a side length AC, and it looks like if I could get AC, this side up here, then if I had an angle in here, I'm going to call that angle dot, then I can work out CH. Do I have that? Do I have those things? Yes, I do. But before I go any further, let's work out, make a mathematical statement about what I can do here. Now I can see that CH is going to be equal to AC times the sine of angle dot. So it's the hypotenuse, AC, times the sine of angle dot. So we need to work with the triangle that's got AC in it. We can see that because we need to know AC. So I'm going to redraw that triangle because there's no way I can work in that diagram. So I'm going to redraw that triangle. Okay, again, very important to label our corners because obviously we've got several triangles happening here. Put all the information on. We want to be able to match them up. We've got 62 in there. Okay. Do I have enough information here to work out AC, this length along here? No, I don't. So what do I need? Let's think. Okay, we really need an angle, some angles, don't I? So I've got 2.5. Okay, these two sides are the same, so I know that two angles are the same. So this angle here and this angle are going to be the same. So 2 squares plus 62 equals 180. If you work that out, you can figure out that a square is going to be 59 degrees. But I won't, that's not necessarily part of our working, so I'll just clean things up a bit and I'll put that straight in there. 59 and 59. Okay, so now we actually do have enough information here. If I use the sine rule, I can link AC to sine 62. So I can write down AC over sine 62 equals 2. I should probably have, so we can just get rid of this without making too much of a mess. Dear oh dear, I'm going to have to do this. I'm going to have to pause and clean. Okay, then I can see that the other one I can tie, doesn't matter which way I go, is 2.4 over 59. So I can write, sine 59, sorry, 2.4 over sine 59. Now, I'm going to just break out just a little bit here because I can. I'm going to, for those of you, some of you, when you get the solutions, you'll see that I didn't actually use sine rule. We added another triangle. We stuck with right angle triangles, and we did another triangle. I'll just do this one roughly because I'm going to take it away. I just want to do this to show you something. Again, I need to have labels, so I'm going to call that O, and that's where the right angle is, so I know the O goes there, and this is next to the right angle here, so that's A, and this is B. Now I know that in here is half of this angle here, so that's obviously 31. Now if I know AO, this distance here, I can obviously work out AC because it's just twice as much. And I can see from here, because it's a nice right angled triangle, I happen to know that BA, oh sorry, I forgot to write that on, didn't I? Write on all the information. I know the hypotenuse, so AO is equal to 2.4 times sine 31. Now, then of course, AC equals 2 times AO, as we said before. And then we can go back and get our answer. We remember eventually trying to get back to what x is. But I don't want to do that because it's another triangle, and it's just more algebra. So I'll leave that there just for a minute in case if somebody does want to go down that track, you can work that way. Okay, this is really weird. I've got no idea why it's done this, but the background has changed to blue, and I can't immediately figure out how to change it back. It might be a time thing because I'm using the free version. They probably only give you a certain amount of time, and I've taken phone calls and all sorts of things and paused this. Anyway, we better move along. I think I can still work with this. So obviously if we go back to this, we can see that AC is going to be 2.4 over sine 59 times by sine 62. Or you could just put that into your calculator. Again, I'll just write this, I won't leave it there. You could write in solve x over sine 62 equals 2.4 over sine 59, solve for x, hit control enter and you'll get your answer. But I'll let you do that, just take that all back. So now we're nearly there, So let's just pause for a minute and just make sure we've got everything set up, because as I've said in the announcements, it's so important to set up all your diagrams and everything you need before you start calculating your maths. If you've started to work out CH down here or one of the other ones, and then you're sort of going to the next triangle, you're going to, unless you really know what you're doing, you're going to get yourself in a mess. So let's see. Let's just backtrack. If we know AC here, then we know AC here. we know AC there, then we can work out CH. Oops, hang on. Whoops. I don't know this thing. I don't know the dot angle. Where can I get that from? Okay, I'm going to put it back on the main diagram up here, and let's just look and see if we can figure out something we can use. Because this is vertical, look at this. We can have a right angle there, and that means we know there's 59 in there from over here. Okay, so to be true to what I've said, I'm going to put my 59 in there, and we can see that angle dot is equal to 90 minus 59. Now let's just think again, is there anything else we need? We've got the angle dot. Once we've got the angle dot, we can work out CH, that's fine. Once we've got CH, we can, what do we do with CH? CH, once we have CH, of course, up here, we just add 0.9 to it and we get our answer, our final answer. Good. Now, this is a bit like question 12 in week 8, where they forgot to add on the height above the ground. But anyway, okay, so we know our angle dot. We know AC. Do we know AC? Yes, we worked out AC over here. So we've got AC, so that goes into there, that goes into there. We know our angle dot. We can work out CH, so that means we can get back to X. So everything looks like it's set up, ready for us to start doing our maths. Now I've taken an awfully long, I've laboured this point, but you can see, and I'm going to let you finish that off because everything you need is there. I've laboured this point because it is just so important. If you set all this up first, if you're not sure whether it's right or not, you would do this in a sack, because this problem might take 20 minutes or 25 minutes in a sack to do. You go away, you have a drink, you come back, you look at it, you run through it again, yes, it's all okay, and then you work it out. Okay. As I said, the solution when you get it, we did it a slightly different way, but this way you only have to use 2 triangles instead of 3. So I hope this has worked for you. If you want to discuss it any further, please contact your teacher.